Hey guys, today we're gonna start to focus on what is called a cone of vision. And before everything else, let's look at the material. So if you guys will be so kind, make sure that you have some tape. Make sure that you have some extra paper, whatever paper you guys use, just in case. And you'll need your mechanical pencil, you'll need your color pencils or microns, and you'll need your eraser. Also, for today, if you guys will be so kind, you'll need a compass to make circles. You need a protractor to measure angles, and you need one of those 90 degrees. If you guys look, let's put it like this so you can see it, 90 degrees triangles. Now, when we talk about cone of vision, guys, let's say that you look at someone, you know, from a top. So we'll have the nose, we'll have the eyes, we'll have the other eye, you know, head. Here it is. All those ears, all those beautiful things. So at the eye level, if you guys look, this will be the eye level. We're gonna have what's called the horizon line. Now, let's say that this fellow looks at this object, which is somewhere here, like a tiny box, let's say. So from in between his eyes, we're gonna have a line which is perpendicular on the horizon line. Wherever this line, which is also called the distance line, so it suggests how far away someone is from the horizon line, basically. Now, wherever it intersects the horizon line, we're gonna have what's called CFP, or the center focal point. And cool. Now, guys, when we look at an object as this guy to this box, you know, we tend to focus on these things. Everything else, what's off, if this guy were to stretch his hands here, but he still looks face on, he couldn't see his he couldn't see his fingers, right? Now, if this guy brings his hands ahead in front of him, he can see his hands. And that's how happened because of what's called the cone of vision. Or our range of vision. We cannot see size, unfortunately. Our vision, our cone of vision, it's at in between 45 degree and 60 degree. So going back to this guy, you know, so here it is, the eyes, once again, the horizon line. We have in between his eye, this line. We have the central focal point, you know. So what's gonna happen? When and we had that box, if you guys remember that object. So in order to find the cone of vision is somewhere in between 45 degree and 60 degree, right? Now, in order to find this cone of vision, you usually need a protractor. So in order to use this protractor, what you're gonna do, you fix the protractor in such a way that the 90 degree, I don't know if you guys can see it, let's make it a little bit closer. So the 90 degree, it's exactly on the line which suggests the distance. So I would have it here. Then if you guys look, from 90, I will go to 120. And from 90, I will go on this section to 60. Then if I were to connect them with my... So basically, this suggests our how much can we see, our range of view. So I would have here in between this line, this is called stationary point, and here I would have 30 degrees, and on this section I will have 30 degrees. So remember, so when we draw it, we're gonna always have the horizon line. We're gonna find the central focal point, which does not have to be in the middle, guys. We're gonna fix from the central point this line which goes downwards. Eventually somewhere on this line we're gonna have our stationary point, and we're gonna try first to figure out the cone of vision, its size. When we draw it in perspective, the cone of vision usually suggested through a circle, as you guys will see. So I would have, if I were to draw it, I don't know if you can see this circle actually. Basically, this will be, I will make it a little bit heavier so you guys can see it. So this will be my cone of vision. Whatever I would draw outside this is going to be distorted. So let's look to see step by step what you guys will have to do in terms of drawing this. So first step, if you guys will be so kind, always start by having your picture plane. And this could be the whole page, or you can just draw a smaller section. No, just a smaller rectangle or a square on your piece of paper. Think of the picture plane as a piece of glass in front of us, and think of it as similarly to a window when you look outside and you have a view basically, and this view can be composed by buildings, by trees, so that is the picture plane, is the translation of the outside world, or the space where we create that translation. The next step, what you guys will have to do, is to fix your horizon line. Now, for the purpose of this exercise, I fixed it just slightly above the middle. However, the horizon line suggests your eye level, or how you are positioned. If you are seated really low, your horizon line is going to be low. If you sit on the floor, let's say. If you sit on the ladder, let's say that you climb a ladder, your horizon line is going to be higher because your eye level is higher. If you stand straight up, we can, will be slightly above the middle according to, we can measure those parts. Also fix your ground line, if you guys will be so kind. Once you have your picture plane, you have your horizon line, you have your ground line, fix a central focal point. For the purpose of this exercise, I fix it in the middle. Once again, it does not have to be in the middle. From the central focal point, take a line, make it a little bit longer. This line suggests the distance from the viewer to the horizon line, but also on this line, we're gonna have our stationary point, or where exactly the viewer is placed. Then once you have your picture plane, you have your horizon line, you have your ground line, you have the central focal point and the line which is going to suggest the distance from the horizon line to the viewer eyes. We're going to suggest the cone of vision, which basically, once again, is just a circle. That's how we suggest it on a flat surface. And make sure that if you guys look, it's slightly off the picture plane, it's a little bit bigger. Then, if you guys will be so kind, at this point, we're gonna need to figure out the cone of vision. So as you have your picture plane, as you have your horizon line, as you have your central focal point, as you have your cone of vision, take your protractor, if you guys will be so kind, and how you use the protractor. So if you guys look, we have this line which suggests, the blue line suggests the lower part of the cone of vision. Then very lightly put your protractor in such a way that it intersects the lower bases of the cone of vision. So if you look, it matches the 90, which suggests basically half of an arch, basically half of my circle. So from 90, I would look where it intersects. The cone of vision are 60 degrees, so it's just right here. Then on the other side, I would look where it intersects from 90 to 120, and it intersects this blue edge of the cone of vision. So I'll fix it, 120. Then very lightly, the next step will be, as you have your cone of vision, as you have, picture plane, horizon line, ground line, we're gonna try to follow where is the intersection between the cone of vision and the horizon line, and mark it with a point. Then we're going to start to look where is the intersection of this section of the cone of vision with the horizon line, and mark it with a point. The next step will be, from the intersection of the cone of vision with the horizon line, fix a line which goes through the 60 degree. So take this line and let this line connect with the line from the central focal point downwards. So just connect it. Then we're going to do the same from this intersection of the cone of vision with the horizon line. From this point, we're going to take a line which goes through 120, and it stops on the distance line. Wherever the two intersect, we're going to have the stationary point, or the viewing point. From this point, we're going to start to find our two vanishing points, guys. So we already found the stationary point. We have the cone of vision. Now we have our picture plane. We're gonna fix a vanishing point on the horizon line, always on the horizon line. From the vanishing point 1, we're gonna connect with a line to a stationary point. So you have this red line. In order to find the second vanishing points, in 2 points perspective, the vanishing point happened to be at a 90 degree. So in order to find a 90 degree, if you guys will be so kind, what we're gonna do? So we're gonna fix our protractor, and if you guys look, we're gonna have the middle of my circle will be. So I will fix this black line, I will fix it on my red line. Then if you look at the intersection, exactly where I have the 90 degree, I will put it to be exactly on the stationary point. Then you're gonna mark it very lightly, and then we're gonna take from the stationary point through this line a diagonal until it intersects the horizon line. That's where my vanishing point 2 is. Let's work this together so you guys have a better understanding. What I will do from the beginning, I would connect this paper just to make sure that I have enough space and there are no surprises. So let's tape this. Let's make sure that it's also in the camera so you guys can see what I'm doing. Let's go a little bit further. It's not quite straight, but here's what it is. We're gonna first fix our picture plane, and I'm gonna make it with blue so you guys can remember. Then I would use, to make it easier, I would use the 90 degree triangle, just so I don't have to measure, and also make sure that all my lines are nice and perpendicular. I would fix my horizon line, guys, so I would fix it a little bit below. So once more I would make it a little bit longer, and this time I will fix also my ground line to get used with this idea. Let's mark it so you remember. This is the horizon line, this is the ground line, this is the picture plane, the blue one, right? I'll fix my central focal point. From my central focal point, I'll drop that wonderful line to suggest the distance line. So I'll just take it a little bit lower. Then I'll take my compass, and please do remember the circle itself should be outside your picture plane. So I will put my compass from the central focal point to outside the furthest corner to have a sense of how big I need to have it. So this is a little bit off. What I will do in a normal condition, I would add another piece of paper. At this point, I will just mess up a little bit my board and clean it later. I would extend the horizon line. The horizon line should intersect your cone of vision at all times, guys. Then I will take my protractor and I will fix it in such a way that the middle line, which suggests 90, it's exactly on the line which suggests the distance from the horizon line to the viewer. And then I will drop a little bit until it intersects 120 here and 60 here on the cone of vision, guys. So if you look once again, the intersection should be between the protractor, we'll do it later, and the cone of vision. Then very lightly I will start to look at the intersection point between the cone of vision and the horizon line. So I'll take this line and I'll have it here, and I will take from the cone of vision and the horizon line, pass it through 120, and I will have it here. So basically that will be my wonderful stationary point. Now I am going to use this stationary point to find the two vanishing points. So let's say that I would fix first my first vanishing point. Let's call it vanishing point 1. From vanishing point 1, I would go with the line to the stationary point. So we'll connect those two. Then I will need to find out the second vanishing point. So I will extend a little bit my horizon line to have it already ready, because I can see that it's quite further away. Then we're gonna take the protractor, fix this middle black line to match on the blue line. Make sure that where I have, if you guys look at 90 degrees, this line which stops exactly in the center, this one should correspond with the stationary point. So I'll match it there, make sure that they are line on line. Wherever I see the 90, I would fix a point. Then I'll take my longer ruler, and from the stationary point I will go through this point which suggests the 90 degree, and I'll take a line which is gonna stop here. This is my vanishing point 2, guys. Now let's say that I would draw my first box, and I'll draw it a little bit heavier. So I will start, as always, the closest edge to me will be, let's call it AB. So I would use those 2 vanishing points. So I would go from the lowest point of AB, and then the highest point of AB. I suggest the direction of one of the planes. I would fix the end of this plane, which suggests one of the sizes of my box. Then from the A and B, I will go to the opposite vanishing point. So you guys have done this exercise so far, you should be fine. So I will make sure that they are all there. Then I will take a vertical line which suggests the height on the back. So let's make this plane a little bit heavier. So I will make it with blue, so you know that those are for the blue. When I use those 2 vanishing points, those set, we're gonna use another set just so you guys can see. And this one, then I will connect, I'll create the top of the box. So we'll go once to the vanishing point 2, then vanishing point 1. I will reinforce those so you guys can see them. Then let's say that this box is slightly transparent, so I'll do the floor and the sides walls. So I'll do them a little bit lighter. I'll go to the other vanishing. So once again, at this point you guys should know you have done this exercise, so you should be more familiar. I would make those dotted to suggest the transparency. Now let's say that I would like to do another box, but to use 2 different vanishing points, because I think that is as if you were to have a table with books which are at different angles, different directions. That means that you'll have different vanishing points. However, they would all be on the same horizon line. So let's say that I will fix my vanishing point here, and from this vanishing point I will go to the stationary point, and then I will need to find the other vanishing point. So I will go back to my protractor. I will put my protractor this edge once again. So what I'm interested, it's in this angle basically, guys, if you look at the protractor. So I'll put my protractor, and I'll realize that actually this is gonna be far off the page. I shouldn't have done that, but it's okay, you guys will have a sense. So I will extend this from the stationary point until it's gonna eventually meet the horizon line. I'll choose another one for the purpose of this one, so we don't waste time by adding more paper. So let's say that I will fix my vanishing point 1 here. I will send it to the stationary point. I will take my protractor. I will fix it. I'll fix 90 degree here, and from the stationary point I'll go through the 90 degree, and I'll see that it's on page, which makes it a little bit easier. So remember, quite often they will be off the page, guys. What you can do is to add paper. Let's say that I'll do another box, so I'll start with the closest edge to me. Remember, the heights are parallel. Let's make it a little bit taller so you guys can see it. Then from the top and the bottom of this edge or this segment, I will go to the vanishing point. I'll send orthogonal to suggest one side of the box or its direction, and then I will go to the opposite. I'll fix somewhere the back edge of the box, and I will make it heavier on the top of the blue one because you can see it, and a little bit transparent behind the blue one to suggest that this one is lighter. Then I will fix my let's say the back edge of the opposite plane, so I'll have it here. And if you guys want to do a cropping, you can go off your picture plane, and this is going to be slightly correct because it's still on the cone of vision, inside the cone of vision. If you guys bring it here, it's going to be slightly weird. So that's how we're going to operate with different vanishing points on the same composition. So once again, fix your vanishing point 1, connected with the SP, and from this point you'll need to have 90-degree, basically 90-degree. If you do not have one of those protractor, you can just use your, so I will put my 90-degree here, and they should match if you guys look very carefully. It's easier to use your protractor, so you have your 90-degree triangle. It's easier to have your protractor for finding the angles of the cone of vision, the 60 and the 120. All right, let's do this exercise.